I see a few people connecting, but we'll let them kind of connect for the sake of time for everybody else who did get connected. So my name is Dave Kluger. I'm the CTO at Storcom. Along with myself, we have Tim Sherbak, who is with Quantum, and he's Enterprise Solutions Manager. And we also have Brandon McCoy with Veeam, a Senior System Engineer, who probably some of you have seen some of our webinars in the past. It's nice to have Tim along with us too. So thanks for joining, Brandon and Tim. Brandon and Tim, you guys can hear me? Just want to make sure.
Yes, sir.
Okay.
Glad to be here.
Good. Real quickly, I'm just going to do a quick overview for any of you who are not familiar with us at Storcom. We are a managed service provider and a top Veeam and quantum solutions providers. We've been doing this for 20 years here in the Midwest, and we have an entire practice built around backup and disaster recovery as a service, leveraging our technology partners in our data centers in the Chicagoland area and Western Michigan. So with that being said, I'm going to let Brandon talk a little bit about Veeam, and Tim will talk a little bit about quantum.
Thanks, David. Yeah, so Brandon here with Veeam. Most of you have probably heard of Veeam at some point, but we are a data protection software company, completely software defined. We don't sell any kind of hardware, appliances. We don't sell any cloud either. That's where people like Storcom come into play. People like Quantum come into play, so that we're not stepping on those toes, and we're allowing you to have the flexibility of hardware and where you're going to store your data. I won't go through all the stats here. The one I like the most is our Net Promoter Score, which you see towards the bottom, which is just kind of an industry survey of, do you like the company, the products? Would you be likely to recommend that to others? And we have always been there at the top, 3.5 times the industry average. So.
Impressive. Okay, Tim.
Great. Thanks, Dave. So Quantum is a well-established technology company. We've been in business for over 40 years, and many of you may know us for a variety of different products. Today, we are very specialized in end-to-end data management solutions in a variety of industries and use cases. Today, we'll specifically be talking about the ActiveScale object storage product, but that is part of our data protection product portfolio that also includes tape storage solutions and DXi backup appliances. We have a very strong partnership with Veeam. All of our data protection products, of course, are Veeam Ready certified, and we're happy to support a large installed base of joint customers with Veeam as well.
Okay, thank you, Tim. So what I thought I would do real quickly is I just want to kind of make sure kind of set the stage for understanding what we're talking about here today. Obviously, this is focused on object storage with Veeam, but for those of you who are not completely familiar with object storage, I thought I'd kind of like lay out the foundation here, right? So storage, as we know it, data storage is written in the form of blocks. All disk is at the end of the day, everything's written to data. Written to disk in the form of blocks, different size chunks of data, which is referred to as block size and so forth. But block storage is the underlying way data is written to disk. But then on top of that, you have these different layers of how you're accessing the data on the disk. So block storage being the lowest level. Then on top of that, where we saw, and certainly this has been prevalent over the past 4 decades, is file systems. File systems sit on top of block storage, and they provide this hierarchy as to finding data that is unstructured in nature, but is necessary that you have some way of finding that data, and the file system, in essence, is what's providing that capability, as well as providing what's called a distributed lock manager, which is how when 2 people are trying to access the same piece of file data on a file system, there has to be some control mechanism in there. Whereas block storage, in theory, can't really be shared at the same time. The same block can't be written to. File systems can control that because there's a distributed lock manager. So we're all used to using things like block storage and file systems, NTFS, Unix file systems that are used for VMFS, for VMware. Those are all examples of file systems. Well, then what you have is object storage, which is what we're talking about here today. And object storage is basically kind of the next level after file systems from the standpoint of it is distributed. It's a distributed architecture where basically data is chunked up. There's a thing called a hash that is basically generated to find out where that block, those blocks which make up the object are being written to. That data is now considered that is now metadata about where these objects are, and all of the participants in object storage, so in the architecture of an object storage solution, have to be aware of this metadata so they know where the data in the object storage is being written to. But what that allows for is an extreme amount of scalability. Tim, I'm sure, is going to go into a little bit more detail on some of the other use cases. And obviously, when we're talking about Veeam backup, we're not necessarily talking about lots of different systems accessing the object storage, but one of the main other use cases for object storage is the ability for thousands of different systems to access the same pool of storage. And object storage is really the next level of scalability. So massive amounts of data, extremely large footprints of storage. And with data growing, it's just become more and more necessary that we have to find another way to store data. I thought also real quickly just go into kind of a little bit of background on object storage. So object storage is fairly new in the realm of storage. I mean, the 1990s, Seagate was really one of the first companies that was really starting to look at putting patents in place. Object-based storage devices command set is a RFP proposal document that was basically written, RFC, sorry, to lay out the foundation for what object storage would look like. A lot of research was done at Carnegie Mellon Institute. So early on, basically they started laying out the design, and basically the two basic premises is that the data is distributed, so there has to be some way to protect the data, and then data is hashed and stored as blocks on storage, and that is the way that the mechanism for finding that data is stored in these hashes. EMC Centera, if anybody is familiar with that solution, that is an early example of an archiving solution that was based on based on object storage. So the Centera solution is kind of predates a lot of what we're talking about here, but it's a good example of where storage companies were starting to see how object storage could be used to archive data. We also everybody's probably at least aware now of S3 protocol, which is developed by inside of Amazon, AWS. So that was a distributed design protocol, and it's based on early file systems, the one called the Lustre file system, which basically was a early adoption of a distributed file system. And this is obviously, when you think of the concept of distributed in the cloud, that plays in very well, because I can have data chunks written into multiple systems inside a data center, multiple data centers, multiple regions, and that is one of the other main use cases when you look at object storage, is the ability to distribute that data across wide regions. And lastly, object storage is exploding right now because of the fact that it has this scalability, as well as low cost in comparison to per gigabyte cost, compared to traditional file systems running on block storage or block storage itself. Last slide here on this part, and I'm going to turn it over to Brandon and talk really about what we're talking about here today with Veeam specifically, but just want to kind of lay out the foundation here, right? Block storage, you have typically high I/O, things like obviously databases always are going to run on things like block storage, directly. Object storage is not the place, at least today, for databases. That doesn't necessarily mean in the future that may not change, and there are examples of things like Kubernetes running in object storage. But lower capacity, low latency is an example of where we're still seeing block storage. Then you have your file systems, which are the semi-structured data, and then object storage, which is completely unstructured data. And also some of the other things that we're going to talk about today as it pertains to security, security and backups, is the concept of immutable files and versioning, and the ability to protect against things like ransomware, which is where another benefit of object storage which really applies to the concepts around Veeam and data protection, as well as Quantum and what they're doing with ActiveScale. So with that said, Brandon, I will let you, hopefully they can provide a little bit of a background on object storage, but I'll let you kind of talk about object storage and how it applies to the 3-2-1 rules.
Yeah, thanks, David. So object storage with Veeam, this is something that we released in backup and replication version 9.5, I think update 3 or 4. And at the time, the only thing you could use it for was archiving your older backups, which is still a great use case when you talk about the price of object storage versus traditional disk-based storage going into a private cloud. So it was a great use case for the offsite, but it wasn't anything you could use. So this 3-2-1 rule we see here, for those of you who aren't familiar, this means having 3 copies of your data on 2 different devices, and one of those being offsite. So your first copy of the data is actually the production data itself, VMware, Hyper-V, physical machines. The second copy is a local backup on disk-based storage, hopefully. And then that third copy is also the offsite on that second media. In backup and replication version 10, we came out with immediate copy mode. So this now satisfies the 3-2-1 rule with object storage. So not only can you have a copy of your backups or your older backups in object storage, you can also have a 1-to-1 redundant copy, which sometimes replaces the need for private cloud storage. And Quantum, like Tim mentioned, is Veeam ready. So we have a Veeam ready website. There's lots of object storages out there, lots of S3 compatibles and the likes, but they're not all supported by Veeam, even if they work. So Quantum is one that has been tested by our product management team. They also support the immutability, which kind of leads me into my second bullet point here. So what is immutability? Well, this means that backups cannot be modified nor deleted for the period of time that you specify. So a couple, 1 or 2 steps on the Quantum side, and then 1 or 2 checkboxes on the Veeam side. You attach that Quantum bucket to your local repository. We're going to get into that a little more later of how it's done. I'm sure there'll be some questions around that. But basically, you have your local backup, and then you have a copy in Quantum's object store, and you place a checkbox that says these backups can't be deleted, modified for the time that you specify. And it's a really great ransomware proofing strategy, as well as to go along with the 3-2-1 rule.
Yeah. One thing I was going to say, Brandon, I know you and I have talked about this quite a bit in some of the previous webinars and talking about new features in version 11 and data immutability within native file systems like XFS, but object storage, right, provides another layer on top of what even things like XFS can do. And I think that's another value add that, yes, we can write data now, using a scale-out repository to an XFS file system and, provide additional protection against ransomware, but object storage, because of the way an object storage solution works, because there is no underlying LUN in essence. There is another level there where that data cannot not only not be written to, but the storage itself can't even be removed. So it's kind of like the, I guess you'd say the Cadillac approach to data immutability.
Yeah, absolutely. I get asked that a lot, because from an immutability perspective, Veeam offers that with Linux, like you mentioned, and some of these object storages like Quantum. And I just like the whole approach of object storage being completely offsite, completely removed from Veeam, other than the bucket access, which has been, locked down. So.
Yep. Tim, this is, you want to talk a little bit about Quantum and ActiveScale and what you guys are doing? I think it's, important to still point out some of the other use cases for object storage, because obviously it's not just used for repositories.
Sure, that's absolutely true. And to kind of reinforce one of your initial points, object storage has really crossed the chasm into being a mainstream technology, increasing adoption by application vendors such as Veeam, as Brandon described. And in addition, there's many basic tools available on the market and freeware that allows you to integrate object storage into your environment. Plus, it's fully scriptable, and so it's easy to build in-house utilities integrated into your DevOps model. So backup and retention, of course, is a long-standing use of object storage, particularly for secondary keys and disaster recovery. Because not only is it scalable and resilient, but it easily accessed from over any distance, either over your wide area network, your local WAN, or over the internet. And so it makes it very easy to get your data off-site and yet still online and very easy to very easy to recover. And so it's a great solution for the support of secondary copies and disaster coverage. For compliance and long-term retention, that you can do that both in the forms of periodic backups, which we're always conscious of, but it's also credible and a useful technology for non-active data. So it's an easy archive target. And for example, with Veeam, you can use Veeam to catalog and put the data out on the object store and consider deleting the production data. And that's possible because the ActiveScale object storage is itself self-protecting. And so it's very durable, withstands site failures given the right configuration. And so makes for a very robust environment for archiving data as well. Talking about other use cases here, there's a variety of use cases. Largely what you'll see is it's really used in environments where there are large data sets, right? This is a low-cost alternative to other storage solutions that are available, and it's extremely accessible both locally and, as I suggest, across the network, across the WAN, across the internet, depending on your networking environment. And so you'll see object storage being deployed in genomics, satellite imagery, Internet of Things type, sensor type applications, video surveillance, medias of all type, audio, video, imagery. And then one emerging scenario, which we see a lot of, is what is referred to as active archiving. That's kind of this scenario where people don't want to throw away data, and they actually see scenarios where they actually need to reuse that data and monetize that data again. So by placing the vast majority of the data on low-cost object storage, makes it such that they can easily bring it back into a high-performance tier, such that they can reanalyze it, have new analysis projects, or monetize it. You know, just think of a movie sequel or an animation house where they have all the models for their characters from movie one, and so they'll bring those back when they're doing the sequel, back from archival storage and into their production environment. And lastly, as we'll talk in more detail with Dave, is storage as a service is an emerging market for a variety of managed service providers such as Storcom, in which because of the scale of object storage and the ability to grow and support a large number of users in a very secure way and provide for performance to meet the requirements of a large number of users and use cases, that it's emerged as a great tool for customers to partner with their local managed service provider and effectively enable them to leverage the data centers of their managed service providers. And so with that, I'll hand it off to Dave to talk a little bit more about that architecturally.
Sure. One thing I did want to touch on, because you mentioned this, and when I was talking earlier about object storage and the fact that kind of one of the early defining characteristics was around this concept of being distributed and that Lustre file system. I don't think I really did a good enough job explaining that, because you mentioned the word durability, right? So one of the things that object storage provides is this concept of extreme durability. I mean, block storage, right? I'm sure everybody on this webinar knows what RAID is, right? I mean, different types of RAID. You got RAID 5, you got RAID 6, which allows for double drive failures. You can do things like replicating array to array, but at the end of the day, the durability is not the same as when you start to distribute chunks of data. And the quantum ActiveScale solution, and I think, Tim, you touched on this, right? So within the solution, center, you're distributing data, and it's not using RAID. It uses something called erasure coding, which basically is another fancy kind of term for a distribution of data. But there's, a lot of different options there for how that data gets distributed and how much durability you want. So within a system, you can have different levels of durability. Then that system basically can then, as you start to build that out and you say, okay, I want to have one system in data center A, another system in data center B, and I want that same volume of data, that same, set of data that you're accessing, can be made durable across multiple data centers, across multiple regions, and that's because of this data distribution. And that is what makes these file systems, the difference between a file system and an object store. A file system can't really do that because you're just basically replicating the files at that point, whereas an object storage solution has this capability built into the underlying architecture of the solution. And I think that's where, again, you said, Sam, I mean, the use cases for this are expanding every day because of it's far less expensive to do it, to use a distributed file system, a distributed architecture, because of the way the drives are written to, but also it also provides that capability of really making sure your data doesn't get lost. So, and that's really, and that's the part that I say, for Veeam, using a repository on object storage, that durability comes into play too. When you think about for compliance reasons and things like that, I want to archive data. Well, if I'm archiving this data, that means I want that data. I do not want to lose that data for any reason. And the higher the level of durability, and if I'm distributing it to, using Storcom storage service and us being a Veeam scale repository backup target, and maybe one level of durability is a single data center, but then you say, nope, I want even greater durability, then we do it across multiple data centers. And that whole architecture is what allows us to do this very easily with object storage. So this is an architecture slide. I'm going to kind of touch on this and then let you kind of take over, Brandon, from here. But you've got your workloads on the customer side over here. Whoop. Sorry. And these are our clients, and then we have a gateway on our side. And basically, the gateway allows us to attach our backup jobs into our infrastructure. And whether we're using a DXi backup appliance or we're using DASD, whatever it may be, and Brandon, you can talk a little bit more about this. What is a scale out repository, and then how does that basically leverage, moving the data as it gets older into this capacity tier, and in this case, Storcom leveraging quantum object storage. Brandon, you want to talk a little bit about scale out repository and kind of that architecture?
Sure. So scale-out backup repositories were introduced before we had object storage integration, and its purpose was to present two repositories to Veeam as one, whether that was two different volumes, two different physical pieces of hardware, pretty much any disk-based Veeam repository, you could create combine those into one. There's lots of different reasons for that in terms of large data sets and where you place certain data. But then once we came out with the object storage integration, we're just piggybacking on top of that. So object storage is not at this time something that you can back up to directly. It is only available through that scale out repository, at least for our core product, Veeam Backup and Replication. It also works with Office 365. That works a little differently, and maybe we can get to that in the question section. But yeah, the scale out repository is a feature of Veeam Backup and Replication that allows you to attach a disk, and in this case, an object storage, to be combined into one repository, and then different retentions can be moved into different extents of that repository.
Okay, thank you. So that's again kind of the architecture. Just want everybody to understand what we're talking about here. And as Brandon said, there's really two different main use cases as far as Veeam's concerned, whether it's the VBR, Veeam Backup and Replication product, or the Veeam Backup for O365. So I think we've kind of touched upon this. Obviously, Storcom, Veeam, and Quantum basically ensures this data protection through a lot of what I just talked about: durability, scalability, options, and so forth. So obviously, one of the main things that's on top of mind for everybody right now is, ransomware, malware, and so forth. That's where things like object storage provide another layer of protection that you just simply can't have, in traditional file systems. Heidi, I didn't really stop at all during this presentation to see if there's any questions previous to this, but do you have any other questions we want to go over?
Yeah, the first question is, how does Veeam work with object storage, and which Veeam products can leverage object storage?
Sure, I'll take that one. Great question. Yeah, so I kind of figured we might have some questions around that, kind of what we were alluding to earlier. So Veeam backup and replication is our core product, and having your repository added to a Veeam server gives you that scale out functionality. You can use agents. You can use Veeam backup and replication. So different products can back up to a scale out repository, but in terms of how that works with object storage, Veeam backup and replication is that core product for the scale out. Also, we have it for Office 365, like I mentioned. This works a little different. So rather than having a scale out repository, we instead have a caching disk. So this would be, your Office 365 backup server with a local disk. Doesn't need much storage space. The data is going to pass through that disk and then go directly to object storage from there. The disk left behind is for indexing and metadata. So the difference is you don't have to send all of the data to a disk first. It just has to go through there, and then all of the data can be pushed to object storage from there.
I think this ties in. Somebody wanted you to speak to the Office 365 integration.
Yeah, so that's how that would work. Office 365 backing up through a disk and then ultimately landing in object storage. I will say one other thing. So we talked about immutability earlier. So just to be very clear from a technical perspective, immutability in terms of what Veeam considers things to be immutable is object lock within an object storage like a Quantum or some of the others. And with Office 365, that currently isn't supported. So you can back up to object storage with Office 365. You can encrypt the backups there, but the you can't do the immutability piece, and that's just the current limitation with the way Office 365 data is stored in something called a JET database.
Let me just add that in that case where you're backing up Office 365 to an object store like ActiveScale, there is versioning available on objects in a bucket. And so in that case, one of the behind the scenes agenda that is going on, kind of independent of Veeam, writing and updating backups, is the fact that multiple versions of those backups exist and can get promoted in the case that something terrible happens. And so that versioning on the backside of the object store, fully transparent to Veeam, can add additional protection for an Office 365 type scenario.
No, that's a great point, Tim, because I think that is one of the differences when we talk about immutability. When Brandon talks about it, he's talking about from the Veeam application layer. You're talking about from basically the storage subsystem layer. The two things are separate, and you're right, because even if you think of just a basic snapshot on a SAN, the same concept, right? I can go back to a point in time prior to when the data got encrypted, or if it was ransomware, the data got encrypted, or there was corruption of the data. I can roll back to a previous point in time, and at least in my definition, I think Tim, you were saying the same thing in quantum fields. To me, that's still providing immutability. I have a way to protect myself to get back to an earlier point in time. Now, Brandon, to your point, no, it's not done through the Veeam interface, so it's not being controlled by Veeam, but it's another layer outside of Veeam to provide another layer of protection. So, Heidi, do you have is there any other
Yeah, the next question, and you guys all kind of touched upon it, was how does object storage help with ransomware and an overall solid backup strategy?
Yeah, I mean, I think that's kind of what we just went over. I mean, basically, object storage. Well, and again, it's more important to point out here, right? So today, as Brandon pointed out, that scale out repository. So we can do immutability with the XFS file system. So Storcom now leverages the XFS file system for all repositories. So that is a feature that Veeam took advantage of, which is a native Linux feature. And if without even using object storage, we can create immutability by not allowing that data to be basically overwritten, changed, or deleted for some period of time. But when you want to start to look at archiving, that's where also ransomware, because the thing with ransomware is ransomware can sit dormant for months, years theoretically, right? And it's been sitting there. You may need to get to some point in time to find the ransomware, and scrub it before, to get data back to a point in which it's usable. So there are a lot of different use cases for why you'd want to keep, data around for a long period of time and have it archived. So object storage adds an additional layer there. But that's all part of the overall ransomware kind of approach, I'd say. And Veeam, Storcom, and Quantum are kind of building that all into our solution.
David, I can add a couple comments with regards to object storage and ransomware, because I think it is an important topic. One thing to recognize, number one, about object storage is that the data and metadata are fully encrypted both in flight and at rest. And so there's a layer of protection just in order to support the whole data migration effort. And the authentication model of an object store is very well defined. And so the only, for example, for a Veeam backup, the only person or process that can access that data is the Veeam process. And so you can lock, with proper networking, et cetera, you can lock that down such that it's a very isolated pipeline to get from your Veeam environment to the S3 environment, and fully independent of what distance you're going, right? So you can have a fully protected kind of tunneled environment over your WAN, LAN, or internet connection. So that makes for another added layer of protection. The other thing about object storage too is that this isn't a place where you can log into and run code, right? And so the only way that a ransomware attack can happen is that they've got to be programming in S3 APIs in order to actually access your data. And so it makes it for a far more complicated attack to attack your object storage versus a file system, for example, that is, kind of open in the context of an operating system or a programming or scripting environment. So that helps as well.
Yeah, that's a great point, Tim. I mean, and back to the object storage versus traditional file systems is that, at the end of the day, hackers and people who are writing ransomware, they go after low-hanging fruit. Right? That's the basically, and that's the model today is do as much destruction on wherever they can. That's going to be the easiest for them, which is why also we're seeing ransomware attacks in much smaller environments, because it's easy to prey on and the dollar amounts that they ask for are much lower, but it's also very easy for them to get those, ransoms paid. But to your point, S3 protocol, as of today, there's no known ransomware that has been written to attack that protocol. Why? To your point, Tim, it's very complex, and I think there's still plenty of, unfortunately, there's still plenty of other territory out there right now to go after that nobody's wasting their time yet on this. Not to say it's not impossible, and it'll never happen. But I think there's still plenty of SIF shares out there for people to go after right now. They don't need to waste their time on object storage. So object storage is still the safest place to store data from that standpoint.
Right. It's your your last fortress of data of sorts in order to guarantee yourself a recovery strategy.
Yep. Heidi,
Yeah, I think you guys touched on this a little bit, but from an immutability standpoint, what's the difference between hardened Linux repository that we're using and object storage?
I can. You go ahead. You guys, somebody else can answer this one. We've kind of touched on this again, but we'll go over it.
Sure. I mean, some of the things that I said about S3 generally, I think truly apply when you look at a Linux repository. One of the things that I would say is a little bit different is S3 objects. It's a get put model, and when you rewrite an object, you're really not modifying the original object. You can only copy or delete objects into the environment, and so that makes it very different from a file system where you can write in place. The other thing with the S3 protocol compared to like a hardened Linux repository is it's available over any distance, right? And so a hardened Linux repository is a good solution for your in-house data center as a hardened, immutable repository for fast recovery, which you generally want for your primary backup. And then object storage would be that offsite immutable copy that you put in Storcom's data center, for example, as we showed on the diagram.
Yep. Good answer. Heidi, we got any others?
Can you talk about certain levels of ransomware changing data?
Certain levels of, well, I mean, ransomware. I think maybe I'm not 100% sure I'm going to answer this correctly, but I mean, ransomware. If it's ransomware that's going after data and trying to manipulate the data by encrypting it, and then basically holding that data hostage, that's where we're talking about having copies of this data in other locations that can't be accessed, and that's what makes them immutable, as well as things like air gapping, where you don't have connection to that offsite data center, other than over this, in our case, a Cloud Connect. I don't know that there's necessarily, there's different types of ransomware, and there's certainly different levels of how invasive the ransomware can be, but any ransomware, you need to see as a threat, and you need a protection model in place, and that's what Veeam and Storcom and Quantum are providing with the solution is a way to protect against that. Hopefully that maybe clarified for where that question was from.
Well, so far, those are the only questions that I have.
Okay. Well, I hope this was useful for the participants that have joined. And as always, thank you very much, Brandon, for joining and providing good insight and answers as to where Veeam fits in. And Tim, thank you for joining also and talking about the Quantum product and how it comes into play. And for any of those of you out there who would like to learn more about this option and solution, and how could we help raise the level of protection in your own environment, we certainly would be more than happy to have follow-up conversations. And I think Heidi's going to be sending out some follow-up emails and seeing if there's any questions or if anyone would like to meet. And with that being said, thanks everybody for attending today. And hopefully this was a good use of your time.
Thanks, guys.
Thank you, Brandon. Thank you, Tim. Thank you, Heidi, for hosting this.
Thank you, everybody.